Player Sounds. The player sound group contains many samples and is divided into three main categories: locomotion, voice, interactivity. Let's start with locomotion, which refers to the player's ability to move, and is further divided into sounds generated by feet, like footsteps, and other body parts, like clothes. In this game, the sound of footsteps depends on the surface type and the player's movement type. Necessary footsteps samples were found in my sound cue library. They were edited in Reaper, and then bounced to Wwise. In the middleware, a surface switch was created for tile, wood, and carpet. And the blend track was used for the player's movement type, which I found quite useful for creating a smooth transitions between different movements. In Unity, I implemented a surface switch system based on Omniserpher's switches and footsteps video, which in essence uses a raycasting logic that checks the material's name and changes the switch accordingly. The movement switch is a bit more complex. It uses Unity's character controller as the primary movement system and animator to match the movement type with the corresponding animation. First, I created a movement system with matching booleans for each movement state. These booleans execute when local conditions are met. A float multiplier is applied in the forward and right vector calculations to adjust the player's movement speed. However, the run speed didn't match the run footstep playback, so I used vector3 distance to modify step distance when necessary. The next step was to bring the movement system to animation. In Animator, necessary character animations were added, and they were set to transition between states by using booleans that can respond to those in the movement script. After that, in the player sound execution script, the RTPC values are set based on these booleans. For the crouch animation transition, the camera's wide position was made dynamic, and necessary sound effects were created. Inspired by Alien Isolation, I wanted to recreate a similar sound system that plays when the player rotates, generating floats and scuff sounds to enhance the sense of involvement with the in-game character. To achieve this, I used the quaternion Euler function to return rotation values based on the mouse's x-axis input. The current rotation value updates constantly and is compared with the previous rotation value, which is initialized to 0 but updates at the end of each cycle. The order of code execution is crucial here, as a split-second delay between lines allows for the creation of the required angle difference. If the angle is large enough and a 3-second cooldown has passed, a coroutine is triggered. The coroutine adds an extra delay to avoid the overlapping of scuff sounds. After the delay, based on the angle difference value, a specific boolean is executed, which determines whether to play low or high intensity scuff sound effects. The jump effect uses similar logic to the scuff sounds, but instead of rotation, it relies on the time falling down variable, which activates when the player is not grounded, or, in other words, in the air. There are also two Wwise switches that handles low and high jump sounds, while an additional RTPC is applied to introduce tonal variation, as there is only one sample per jump type. Voice. The voice group contains breath sounds such as inhale, exhale, peaceful, and scare breaths. Because these sounds are quite specific in their characteristics, it was easier to record them myself rather than search for matching sounds in my library. So I hopped in my cupboard with my Tascam DR40X to start recording. I was a bit cramped by the clothes inside, but on the other hand, they helped absorb the echo, which added a claustrophobic and unsettling feel to the recording, especially when it's playback in the game. But before implementation, I needed to remove the noise from the recordings and pitch the voice up to match our female avatar. In Wwise, the breath sounds were systemized, and the breath control RTPC was created to dynamically adjust the intensity of the inhale loop, based on how long the player has been running. In the Player Sounds script, inhale sounds are triggered when the player switches to a running state and the increase time variable exceeds 1.5. This ensures that inhale don't trigger immediately when the player starts running. To stop the inhale loop, a boolean is player run previously set to true when an inhale coroutine is triggered, and resets to false once the player leaves the running state. Exhale sounds are triggered after the inhale sounds stop, using another boolean time after running enabled. Exhales only play if the player has been running for nearly 5 seconds. The peaceful breath is triggered randomly, with 1 in 3 chance when the player is idle, while the scare breath is scripted to play when the player first enters the event hall. Interactivity. In the game, a player can interact with objects like a flashlight, doors, and items such as a key or record vinyl. Most of these interactions follow straightforward audio programming. When the player enters a collider and presses a specific key, a sound effect is triggered. However, some interactions involve additional branch logic. For example, there is a locked door that requires a key. If the player hasn't collected a key, a locked door sound effect plays. Once the key is collected, the door opens with the corresponding sound effect and animation. Also, the repeated open action was ensured not to be executed with the else if statement.